Hello students, a very good morning. I am Chandrasekhar Trivedi and today I am teach you topic electricity. All you know, electricity is a very important source of energy and it is a widely used form of energy in our daily life. We use energy for various purposes like lighting our houses, operating ACs, refrigerator, washing machines, geyser, toaster, washing machine and many other electrical appliances. We can say various works depends on electricity in our daily life. Students, all you know that every matter is made up of a very smallest particle known as atom. Every matter is made up of a very smallest particle known as atom. And every atom is made up of a very smallest three particles known as electron, number 2 proton, number 3 neutrons. Electrons are negative charge particle and it carry minus 1.6 into 10 to the power minus 19 coulomb charge. Proton carry positive. Proton is a positive charge particle and it carry plus 1.6 into 10 to the power minus 19 coulomb charge. Coulomb is the unit of charge. Neutron is electrically neutral and it do not contain any charge, means no charge on neutron. So there are two types of charges, positive charge and negative charge. So type of charges, there are two types of charges. Number 1, positive charge. Number 2, negative charge. Positive charge and negative charge. Like charges repel to each other. Like charges repel to each other, whereas unlike charges attract to each other. Like charges repel to each other means 2 plus charge repel to each other, 2 minus charge repel to each other. Unlike charges attract to each other means plus charge attract to negative charge attract to positive charge. Every atom inside every atom there is a very small place at the center which is known as nucleus. In every atom there is a very small place at the center which is known as nucleus, and it contains two particles, proton and neutrons. Protons are positive charged particles and neutrons are electrically neutral. So nucleus is positive charged place. Around the nucleus there are certain energy levels in which electrons are revolving. These are the energy levels in which electrons are revolving. The electrons present in the outermost cell. The electrons present in the outermost cell are known as the valence electron, and these valence electrons decide the characteristic of any material or any substance. Every atom wants to complete octet in their outermost cell. Why every atom wants to complete octet in their outermost cell? Because it wants to achieve inert gas configuration. Means octet is the inert gas configuration. Means if any atom complete 8 electron in their outermost cell, then it is chemically inert. So for completing their octet, it take parts in the bond formation. Bond formation. If there are some electrons left in the outermost cell after bond formation, then these extra electrons which are present in the outermost cell are known as free electrons. Student, listen carefully. Free electrons is a very important topic. Free electrons. So what are free electrons? The electrons which do not take part in the bond formation, or unbonded electrons. Electrons which do not take part in bond formation. In bond formation, or unbonded electron. Unbonded electrons are called free electrons. On the basis of presence and absence of free electrons, substances are classified into two types. Number one, insulator. Insulator are those substances which do not contain free electrons. Insulator are those substances which do not contains free electrons. do not contain free electrons, and it does not conduct electricity. It does not conduct electricity. For example, dry wood, paper, plastic, rubber, etc. Number second, conductor. Those substances which contains free electrons, are called conductors. Those substances which contains free electrons are called conductor, and it can conduct electricity. So conductors are those material or substances which contains free electrons, and free electrons are those which are present in the outermost cell of any atom inside a material or substance or element which do not take part in the bond formation. For example of conductor, all metals, alloy, etc. Let us discuss a small activity. If we take a small plastic scale and rub with hair and bring it near the small piece of paper, then it will attract the small piece of paper, and many times we and some students also perform this activity in lower classes. So when we rub a scale with our hair, then it will attract a small piece of paper. Why it will attract the small piece of paper? Because when we rub the scale with our hair, then some electrons transfer from our hair to the scale, and the density of the electron at this place is very high, and this scale is made up of plastic, and it is an insulator. It does not contain free electrons which can transfer these electrons from this place. That's why the density of this negative charge is very high at this place, so it will attract the positive charge, small piece of paper. In this case, charges stay at one place, so it is known as static electricity. Static electricity. So when charge stay at one place, this type of electricity is known as static electricity. In place of plastic scale, if we take a metallic wire and rub with hair, then what will happen? The electron transfer from hair to the metallic wire move from this place and it is evenly spread all over the surface of the metallic wire due to the presence of free electron, because it is a metal wire and it contains free electrons. So in this case, these negative charge electrons move from one place and the density of electron is very low at this place, which is unable to attract the small piece of paper. So in this case, the metallic wire do not attract the small piece of paper. So there is charge in motion. So this type of electricity is known as current electricity. Current electricity. So there are two types of electricity, static electricity and current electricity. When charge stay at one place, then it is static electricity. When charge in motion, that is known as current electricity. And in this chapter we study about the current electricity. So what is and it is a current electricity is normally known as electricity. So what is electricity, or we can say what is the definition of electricity? Electricity. So flow of charge is called electricity. Flow of charge is called electricity. Now there is one more point. Electric potential. Electric potential. What is electric potential? When this charge moves from this place, if any particle move from one place to another, then it do work. So the definition of electric potential: electric potential is defined as the work done by a unit charge on moving from infinity to any point in an electric field is known as the potential difference of that point. Listen again. Electric potential is defined as the work done in an electric field when a unit charge moves from infinity to a point. It is known as the electric potential of that point, and it is represented by capital V, and its SI unit is volt. Now potential difference. Potential difference means difference in potential between 2 points. So what is the definition of the potential difference? The work done by a unit charge in an electric field on moving from one point to another. Means if any charged particle moved from one point to another, then the work done by a unit charge or that charge is known as the potential difference between these 2 points. If W joule work done by Q coulomb charge on moving from A to B, then potential difference is equal to work done by total charge, or V is equal to W upon Q. The SI unit of potential difference is volt, and it is measured by an instrument known as voltmeter. It is a very high resistance device. Voltmeter is a high resistance device. And it is always connected parallel combination in an electric circuit, and it is represented by a symbol and every voltmeter contains two terminals, one positive and another negative. Positive terminal connect to the positive terminal of the battery that is connected in the electric circuit, and negative terminal connected to the negative terminal of the battery that is present in an electric circuit. Since voltmeter is a very high resistance device, that's why it is always connected in parallel. All high resistance device always connected parallel in an electric circuit, and low resistance device connected in series. The combination of resistance is later discussed in this chapter. Okay students, thank you.